Science!
Welcome to part 3 of our brand new series, Humanity in Space. In parts 1 and 2, we took an in-depth look at the history and science behind spacesuits and spacewalks. Humanity has now made it to space and has walked among the stars, and even on the moon, but those are short trips compared to the time that astronauts now live and work on the International Space Station. But that space station isn't the first of its kind. With the idea of the space station, we can once again look towards science fiction as the precursor to the modern-day ideas. The first mention of something resembling a space station was in Edward Everett Hale's The Brick Moon, which was published in 1869. The story tells of a 200-foot brick sphere that is meant to orbit the Earth as a navigational aid for ships, but it is accidentally launched into space with people inside. The term space station was coined some 50 years later by Romanian rocket pioneer Herman Oberth. Oberth published 2 papers, The Rocket into Interplanetary Space in 1923 and The Way to Space Travel in 1929, which talked of space stations being refueling stations for rockets and to monitor the weather on Earth. Speaking of Oberth, he conceived a 100-meter-wide concave mirror that could be used to reflect sunlight onto a concentrated point on the Earth. During the Second World War, German scientists ran with this idea, developing the sun gun, a superweapon that could be mounted on a space station to focus the sun's energy to boil an ocean or burn a city. It was never completed. Oberth also started to teach and mentor a young scientist by the name of Wernher von Braun. Von Braun was handpicked by the German military in 1932 to develop rockets for the war effort and was secretly moved to America as part of the military project Operation Paperclip. Von Braun is known as the father of rocket technology, but he also developed some of the first highly detailed space station designs. In fact, appearing on Walt Disney's Tomorrowland series in 1956, von Braun brought his wheel-shaped space station idea to the public. This station would rotate to provide an artificial gravity and also be an orbiting laboratory and a stepping stone for missions to the moon. While this idea was never built, a decade later it inspired the station featured in 2001: A Space Odyssey. Futuristic space station ideas almost became a reality in 1958. When NASA was created, the first mission was getting an astronaut into space, and the second was to develop a space station. Exploring various wheel-like designs, these were tested into the early 1960s, but the focus was shifted to a lunar landing after the Russians put the first human in space. While many of the first ideas detailing what a space station could be were never actually created, they led the way for the science and technology that eventually would become the first stations orbiting in space. In April of 1971, the Soviet Union launched Salyut 1, the first space station of any kind into low Earth orbit. Salyut 1 proved to be a successful station and was 66 feet in length with several compartments. The transfer compartment was equipped with a docking port for the Soyuz, and the docking system developed is still in use today on the International Space Station. The main compartment was pressurized and was where the astronauts would work and sleep, and the auxiliary compartments contained various scientific equipment, engines and batteries, and life support. The first crew was supposed to be the Soyuz 10, but they ran into troubles while docking and had to abort the mission and return safely to Earth. The Soyuz 11 crew became the first manned mission on a space station and remained in orbit for 23 days. Upon re-entry, a pressure seal was broken and the crew died, becoming the only astronauts to technically die in space. This was also due to the fact that they were not wearing pressurized spacesuits on re-entry, which became mandatory after this spaceflight. Salyut 1's mission was ended in October, 6 months after its launch, because it was running out of fuel. It burned up over the Pacific Ocean. Salyut 1 was part of the Almaz space station development being created by the Russian military. In fact, Salyut 2, 3, and 5 were all actually military stations launched under the guise of a civilian space station. The Salyut 3 station actually was outfitted with an anti-aircraft gun and was fired while the station was unmanned at least once, while some reports state it was fired up to 3 times. This is the only known armed crewed military spacecraft ever. The Almaz and subsequent Salyut programs laid the groundwork for space stations, with later models introducing the second spacecraft port, allowing for more refueling and supplies, and crews to inhabit the stations continuously. America followed suit with Skylab in 1973, and Skylab was created by using a Saturn SIVB module, or the third stage of a Saturn V rocket, the same rocket that carried the crewed moon landing missions. The idea for creating a space station out of a part of a Saturn V rocket was first conceived by von Braun himself in 1964, and these initial ideas led the way to what would inevitably become Skylab. The Skylab station included a solar observatory, a workshop, and several hundred science experiments. Skylab was also instrumental in updating the habitability of a space station. Astronaut comfort had not been a concern with previous space station designs, as they were smaller and astronauts stayed for only a short amount of time. Skylab had a wardroom for meals and relaxation and a window to view Earth and space. The astronauts of the Apollo missions complained about the quality of their food, so the food was greatly improved for Skylab, and it has been continued to be improved upon to this day. On Skylab, each astronaut had a personal sleeping area with a curtain, a sleeping bag, and a locker. Skylab even boasted the addition of a shower and a toilet, and this added to the astronauts' comfort for prolonged stays in space, but was also a way to obtain precise urine and feces samples for examination on Earth. Some of the biggest advancements in space station's technology were the ones that accurately could monitor the human body and how it reacts to prolonged time in space. The Skylab shower, in particular, was an interesting way to help improve the astronauts' mental state in space. It had a cylindrical curtain that went from floor to ceiling and had a vacuum system to suck away the water, which was the biggest concern of water droplets floating away. The astronauts would use 6 pints of water, and the water and soap were carefully planned out so that each astronaut could take 1 shower per week. The astronauts that used the shower on Skylab mentioned that it was an enjoyable experience, but drying off was a little tedious, and the entire process from setup to packing the shower back away took over 2 hours. Skylab helped further the scientific discoveries in both space and Earth immensely during its 6 years in space. 3 manned crews stayed at the station, the first crew staying for 28 days and performing 2 spacewalks to repair much of the damage the station had sustained during launch and deployment. The other crews stayed for 59 and 84 days, respectively. The science performed on Skylab included human adaptability and physiology experiments, biomedical research, crystal growth, space physics, Earth weather and geology experiments, and even student experiments, including testing spiders spinning webs in low gravity. The study of X-ray emissions from the sun actually contributed to the birth of the field of X-ray astronomy. Skylab ended its mission in 1979 because the space shuttle program was not yet ready to be able to resupply the station. The demise of the station was an international media event, with many worried that it might re-enter the atmosphere and crash land in a populated area. T-shirts with bullseyes and Skylab repellent with a money-back guarantee were sold across the world, and the San Francisco Examiner offered a $10,000 prize for the first piece of the station delivered to its offices. NASA aimed the station at a spot off the coast of Cape Town, South Africa, but the station did not burn up as expected, and there was a 4% calculation error, resulting in Skylab crashing down into Western Australia, one of the most underpopulated regions on Earth. The Shire of Esperance in Australia jokingly fined NASA $400 for littering. NASA obviously ignored it, but on the 30th anniversary in 2009, California radio host Scott Barley got his morning show listeners to rally together and raise the money, which Scott then flew to Australia and delivered personally. Also, 17-year-old Stan Thornton picked up some of the chunks of the space station off his roof in 1979 and flew to San Francisco to collect his $10,000 reward. Mir was the first module space station being assembled between 1986 and 1996, and it also proved the theory that a station could orbit the Earth for a longer period of time, and humanity could live and work inside the station for a much longer period of time. Until the ISS broke the record, the Mir station had the longest continuous human presence in space at 3,644 days, and 12 out of the 15 years the station was in operation, it was occupied by humanity. Cosmonaut Valery Polyakov still holds the record for the longest single human spaceflight at 437 days and 18 hours between 1994 and 1995. His combined space experience exceeds 22 months. Following the success of the Salyut program, the Mir station was technically the 8th mission of the Salyut program, and the first module of the station, known as the core module, was launched in 1986. When it was complete, the station consisted of 7 pressurized modules and several unpressurized components. The docking module was actually installed by the Space Shuttle Atlantis as part of mission STS-74, and the shuttle docked to the station afterward. The station's assembly marked the beginning of the 3rd generation of space station design, the first generation being the Salyut 1 and Skylab, and the second including Salyut 6 and 7 as they incorporated 2 docking ports. To break down the main 7 modules, first is the Mir core. The main living quarters, the attitude control systems, and main engines are housed here. Next is Cavant 1, which consisted of 2 pressurized compartments and 1 unpressurized for experiments. An X-ray telescope, an ultraviolet telescope, and life support systems were housed here. The next module was Cavant 2, which housed an EVA airlock and carried the Soviet equivalent of the Manned Maneuvering Unit, plus other scientific equipment, including an Incubator 2 unit, which was used for hatching and raising quail. Japanese quail were the first vertebrates to be hatched in space, and in 1990, 8 of the 33 eggs hatched, and they were studied for biological and food source experiments. The 4th module was Crystal, the technology module. This contained various astronomical and biotechnology experiments and docking ports that helped with the Shuttle Mir program. Next was the module Spectre. This served as living quarters for the American astronauts and housed NASA-sponsored experiments. Spectre also featured 4 solar arrays, which generated half the station's electrical power. The docking module, brought up by Space Shuttle Atlantis, allowed for a better way for the shuttle to dock and allowed for more crew and experiments to be brought on board. Priroda was the final Mir pressurized module, and its primary focus was to conduct Earth resource experiments developed by 12 different nations. Mir was visited by a total of 28 long-duration crews, varying in length from 72 days to Valerie's 437-day flight. 104 different people from 12 nations visited the station during its mission. While Mir's time in space heralded a new era in space exploration and science advancement, it also sustained a few accidents that threatened the station's safety. The biggest of which was the testing of the station's manual docking system to dock unmanned cargo spacecraft Progress M33 and Progress M34. Due to malfunctioning equipment, both tests failed, and Progress M34 actually struck the Spectre module, puncturing it and causing the station to depressurize and the module to be permanently sealed off. Mir's contributions to the advancement of humanity in space are vast. We learned about the prolonged effects of being in space on humans and other species. We grew crops, we hatched eggs, and studied the cosmos like never before. Mir's mission ended in 2001, and it crashed peacefully into the Pacific Ocean. And Russia and the US had their sights on a brand new International Space Station. Next week, our space station journey culminates with an in-depth look at the International Space Station, which has surpassed all records and accolades and is set to celebrate 2 decades of humans continuously living in space.